It is well known firefighters face an increased risk of specific types of cancer compared to the general population. The risk comes from exposures to various carcinogens encountered during traditional fire incidents, especially repeat exposures and poor decontamination methods. The Firefighter Cancer Initiative, or FCI, at Sylvester Comprehensive Cancer Center has been working to reduce this risk. The team has been dedicated to understanding and mitigating cancer risk among firefighters for over a decade.
My biggest hope is learning new exposures and new ways that we can teach our firefighters to decrease their risk for cancer.
Inside electric vehicles are hundreds or often thousands of lithium-ion batteries. Lithium-ion fires are quite dramatic. They burn hot, and firefighters often are literally in the line of fire. As the batteries expand, they often explode, with some becoming projectiles that shoot 30 to 40 feet out. Inside these batteries are significant levels of metals and metalloids, such as lithium, nickel, and cobalt, some of which are known carcinogens to humans. And exposure to these hazards through, say, an electric vehicle fire is concerning. Are firefighters being exposed to a potential hazmat situation on these increasing types of fires? Sylvester is leading a collaboration in search of answers. Alongside the firefighters, researchers set up to conduct the first-ever full-scale biomonitoring and environmental sampling of an electric vehicle fire.
What we do today here, it's very important. If we can save one life, that's worth 20 years of research. And maybe save other people as well.
Check, get started in 5.
With everyone in place, a firefighter puts a gas flame under the electric vehicle.
We're actually going to insult this battery to go into thermal runaway. We're going to expose this battery to heat, and we're going to use an open flame. We want to get data of the environmental impact before we start using water or any type of agent on this.
As the fire spreads, the team observes rapid increases in heat, flames, and venting gases. The fire is far from routine. A regular car fire might require about 750 gallons of water, roughly what a fire truck can hold. An EV fire can require up to 30,000 gallons, the equivalent to more than 30 fire trucks. That's a huge amount of water seeping into the area. FCI scientists take samples, searching for clues for the environmental impact of using so much water.
You'll see we do something very similar to like anthropology, where we'll set out a grid on the individual floor to create cell sizes, and we will sample that soil to see if before and after the explosion of that vehicle, any of that soil is contaminated with it. And not only if it's contaminated or not, like what type of contamination is present and how far does it travel.
After the fire is out, the focus shifts to decontamination. Firefighters attempt to remove all traces of toxic metals and hazardous chemicals from their gear. The FCI has developed decontamination methods and educational materials to address contamination issues. But it's unclear if these will be effective against lithium-ion fires. The gear is run through the process and bagged to be sent to the lab to test their effectiveness.
Basically, what we are trying to do is who's our enemy, in what number that is present, how we can stop it. And as we had like 3 different kinds of decontamination, okay, which one is working?
Throughout the process, before, right after, and weeks later, Sylvester researchers conduct biomonitoring through the unique collection of biological data on the firefighters exposed to the electric vehicle fire.
Keep pushing, keep pushing, keep pushing. Breathe in.
Deep breath in.
Now breathe in.
That's it.
Perfect. Okay.
We're collecting blood samples, saliva samples, we're collecting toenail samples to look at exposure of heavy metals over long periods of time. We're also doing expired breath collection to look at heavy metal exposure.
There's definitely too much of an unknown, and we need some of the answers.
The findings from this case study could have far-reaching implications for cancer control and prevention, not just for firefighters and public safety, but for the community.
The quicker that we can identify what we need to handle these types of fires, the quicker we're going to keep our community safe, the quicker we're going to make our firefighters safe.
Through collaborative efforts like this, we can build a safer future for our firefighters and communities by reducing the cancer burden.
We're here at the Florida State Fire College. We have the Fallen Firefighter Memorial out here. We have over 250 names that are on the memorial over the last 3 or 4 years. 75% of the names we've had have been due to cancer.
Being able to do this experiment here at the Fire College only reinvigorates and enforces the importance of this science in trying to protect future firefighters. And if we do our mission correct, both clinically and scientifically, we can prevent and reduce the burden of cancer for them so that that wall and that memorial has no more names of firefighters with cancer.